let's take a look at a couple slightly more complex problems involving conversions between the metric and US systems of measure. Both of these are going to involve medicine because that tends to be a place we see metric units used. The first one says a physician is ordering 20 cc's of an antibiotic to be administered every 12 hours. Well, if I want to know what is that in ounces, and all I have are the charts here in front of us, I'm going to have to break it down into two steps, right? Because where I see ounces down here, it's only related to milliliters and not cc's. But if I come up here, I have milliliters that are related to cubic centimeters. Oh, that's what a cc is, right? So learn the language, cc, cubic centimeter, same thing. So the first step would be to change the cc's, cubic centimeters, into milliliters, because I have that conversion factor. It's going to be very easy. 20 cc's over 1, what we're starting with, times my factor of 1 milliliter per 1 cc, they're a 1-to-1, then my answer is going to be 20 milliliters. Great. Now we can use this second part here and turn our milliliters into fluid ounces. So set it up the same way. You start with what you're given, 20 milliliters, times my factor is 1 fluid ounce to 30 milliliters. I want to make sure that my labels cancel, so milliliters are gone. Will it be left with ounces? And in this particular case, approximately 0.67 ounces. Now, most problems won't break it down for you like that. You're going to have to think through those steps. So I've got the next one here that just gives you the problem, and you have to think through it. If you think you're getting the hang of this, go ahead, hit pause, and see if you could work this one out. It's got a few steps to it, and we're going to talk about it in just a minute. Okay, how did we do? First thing, hopefully you recognize that you have to turn the pounds, the patient, figure out how many kilograms that person weighs, because that's how the dosage is given. It's 6 milligrams per kilogram of weight. We have a slight issue. We have two different conversion factors over here. Did you notice that? We have a 1 pound equals about 0.45 kilograms, and 1 kilogram is about 2.2 pounds. All right, I cheated and took this graphic out of a textbook, and those really should be approximates. They're not exactly equals, but we'll just live with it. If I use the top one, 1 pound to 0.45 kilograms, this is how I would set it up. 150 pounds over 1 times the 0.45 kilograms over the 1 pound. So the pounds cancel, and in this case, I have a multiplication problem, and I get approximately 67.5 kilograms. However, if I had used the bottom conversion factor here, the 1 kilogram is 2.2 pounds, I would set it up slightly differently. I would start with my 150 pounds over 1 times, this time I have the 1 kilogram on top, the 2.2 pounds on the bottom, so I would be dividing to get my answer, and in this case I get about 68.2. Right, so you notice that there is going to be a little variation converting, because we're rounding all of these conversion factors. In the homework, just watch out and see if it gives you a specific conversion factor to use so that your answer is going to be on track with what the system says. Otherwise, we just know there's a slight variation. All right, so for the rest of the problem, I'm going to go ahead and stick with the top one here, the 67.5. So I start with my 67.5 kilogram person, so that's over 1, times, what's the dosage? 6 milligrams per 1 kilogram, so my kilograms will cancel. Then I'm wanting to find out how many tablets to take, so I know that I have 1 tablet per 200 milligrams, and I set it up that way so that my milligram labels cancel, and what I'm going to be left with is just tablets. So across the top we get 405, divide that by 200, that's approximately 2 tablets. Let me know if you have any questions.